That. Okay, I've shared the. So, okay. So, myself, Anuj Rai, and I'm today's instructor on the topic of Hugging Face Transformers. So, let's first go through what I'm going to cover. So, in this session, which will be around between 60 and 90 minutes, we will be learning about the state of art AI model for various NLP tasks with just few lines of code. So whatever the models we will learn are a category of neural network model called transformer. Uh, the architecture is somewhat same what is used in ChatGPT, Gemini, or any modern LLM large language model we are talking about. So here we are just learning about the application. We are going to learn about the application of large language model uh, based large language model based application, and specifically towards the natural language understanding and processing. Here, why we are not targeting any and first of all we will understand the whole workflow, and here our model will be based on very basic model, not high-end model like DeepSeek or Kimi, which are open source, or Llama, which is from Facebook Meta. We won't be using those because those require a high-end computer infrastructure, which consists of hundreds of consumer grade GPU, or at least tens of workstation GPUs. So we don't have access to those things as a individual. So that's why we will learn the application based on the basic standard model, whose uh, you can say the performance or the quality won't be at the state of the art, but it is very good opportunity to learn the basics of the NLP application. So, so first, let's try to understand what Hugging Face is and what transformer are. So, I will again repeat that transformer are a type of neural network architecture. Uh, so, basically, a paper in 2017. Uh, the great revolution, what is happening in today's world uh, through ChatGPT or Cloud or Gemini, is because of one single paper called "Attention is All You Need," which was written by an Indian who was working for Google at that time, Google DeepMind at that time, and that 2017 paper uh, focused that rather than using uh, back propagation uh, for fine tuning model, we can use the attention mechanism where each word relationship with another word, if that thing can be established throughout the sentence, then the model performance improves. So the whole goal about that paper was that uh, the context, what we are talking about. So the algorithm was somewhat different than the previous, how the NLP model were implemented. So in a way, that was the foundation of all the current large language model, whatever, wherever we are using. So you get the idea that transformer is a type of model on which all the current LLM, large language model, are based on. And what is Hugging Face? Hugging Face is a company and open source community that provides a go-to platform for sharing and using machine learning model. So, like how, so for example, how we use GitHub for sharing open source project and sharing your code. In same way, Hugging Face is a platform where you can share your data set or your uh, pre-trained model so that anyone can use it or fine tune it. And Hugging Face provide their own transformer library, which gives access to the thousands of pre-trained model. So instead of training model from scratch, which requires massive computing power, we can use model that have already other trained. So okay, let's get started with our coding. So before we start using Hugging Face, I would like to um, show you. I hope my window is shared. Hugging Face.co.model. Okay, I think I'll need to reshare my window. Let me close the sharing presentation, stop presenting, and then okay. So here, uh, so basically, Hugging Face. Whenever we talk about Hugging Face, we generally talk about four things. One is so when you go to the Hugging Face website, so there are three things which are important to you. So one is definitely the models. Models are the pre-trained model, uh, uh, and generally it is based on the transformer architecture, all the models, and you can filter the models based on the task. So if you are interested in computer vision, you can filter the model based on the those things. And today's our goal is based on the natural language processing. So for example, text classification. So these are kind of pre-trained models. So there are around 1,16,000 model right now for text classification and text generation. And if you can filter, so for the text generation is 3 lakh, around 3 lakh. So for different tasks, there are different specific models out there. So model are the pre-trained weight which you can use in your project. And then if you want to train your own model based on the raw data set. So for example, let's say if we consider this, if you go to the data set, so this ultra data, SFT data, if you go to that and you can browse the, uh, so this is not without signing in, you won't be able to access it. So rather than that, let's see the other data set, maybe this. So for example, this data set, which is from Wikimedia, so they have created their own data set which has abstract entities, date created, date modified, event, so image, info boxes. So they have their own data set with around 7.6 million rows. So this is one of the data set from around 10 lakh data set. So you can, based on your use criteria, you can use the data set to train your own model. So definitely the first is pre-trained model, second is data set, and the third is spaces. Spaces is a place where you can host your own model, which is not free of cost. Definitely, it they charge us for that thing, for the inference. And the fourth thing is their transformer library, a Python library, which you can use in your code, which help you write your own application for the AI application, which can use these pre-trained model, or if you want to use this data set, you can use their library, transformer library, to either load the existing data set, or to fine tune an existing model, or to come up with a new model. So in our today's session, what we are going to do is we are going to learn how to use the transformer model. So the first thing what needs to be done is we have to make sure that okay, now if you are using Google Colab, we can take the benefit of the GPU. So the the Google Colab provides free access to their GPU infrastructure um, for few hours a week. If you are using their free service, and if you are a paid customer, then you can buy more compute resource. So if you use the GPU runtime, then your code will take less time for inference, for fine tuning, or even the other aspect of any aspect of which requires huge computation. So you for in order to do that, you can go to the runtime, change runtime, and you can use either T4 GPU or uh, TPU, any of this thing. GPU is more preferred thing, and you can go ahead and save it, and then it will automatically connect. And then after that, when it is connected, you have to make sure there are set of modules are already installed on your machine. So
Hello, sir. Am I audible? Hello. Sir, your voice is not audible and nothing is visible on the screen as well.
sorry, there was some network issue. So let me share my screen again. Okay. So yes, so I was telling you about the required modules. So in order to use the Hugging Face transformer model, you need to install these libraries, um, and if you are using Google Colab or Jupyter Notebook, if you install, then you will have to put exclamation mark before your pip command. So if you are using Google Colab or Jupyter Notebook, you can install like this. And if you are using your terminal, so in that case, you will have to use without exclamation mark directly pip install whatever the module you are interested in to install. So since my machine already has the transformer library installed, it will say requirement already satisfied. And in Google Colab also, all these library, it will indicate that all these library are already satisfied because these are kind of standard library. Um, so after this libraries are loaded, let's verify our installation. So we'll check what are the transformer version and the torch version.
एक मिनट रुकना. Hello,
Hello, yes.
sir. Can we have this file, the code that you are writing, be shared with us so
Yes,
that
yes,
we can
sure.
do it parallel?
Generally, I share it after the session, but right away also I can share it.
Please,
Uh,
yes, sir. That would be fine. I mean,
sure.
we can do it handphone as well. Thank you.
Yeah, I'll share it in the chat screen. Let me do that. Okay, so I have shared it in our in-call messages. You can check the link. So since all the libraries are already installed, so it will confirm it that required library already satisfied. Now after the installation, we can verify the transformer version and also uh, so basically first of all let's get into exactly what transformer do is. Transformer is a wrapper on top of PyTorch. So PyTorch is a library, the main library, which communicates with the GPU, or in fact, if GPU is not available, with the CPU to compute in an optimal way for the matrix transformation. So basically, the calculation and all those are not directly handled by the transformer, but by underlying another library like PyTorch, which is from Meta, or TensorFlow, which is from Google. So those are kind of two standard library, but PyTorch in these days are very kind of standard library for crunching numerical computation. So transformer loads the PyTorch model. So all these model are written in a PyTorch compatible way. So the model weights are written in a way where PyTorch can efficiently create neural network out of it, or it can be also in a format where TensorFlow can load it or initialize the model. So the choice is ours whether we want to use PyTorch backend or TensorFlow. The transformer is a wrapper on top of PyTorch and TensorFlow. So those are the important things you have to remember. So and recently the Hugging Face has updated their transformer model. So while we learn, we might encounter that certain code. We will encounter that that is not compatible with version 5.0. So we will see and we will try to fix the code. But you have to know that there is a somewhat major change in version 5, which is not backward compatible with 4. So if you are learning Hugging Face, and if you encounter certain code uh, on the net, and if you try to run it, it might be possible that it will say that it is the API is deprecated or this particular functionality doesn't exist, is because of the version transform, because the transformer version 5 has deprecated certain methods or library function. So you have to be you should know about that thing. So before you run any code from the net. So after the version and all those things are confirmed, so we will start our NLP application process. So the easiest way to use transformer is through pipeline, and pipeline is an abstract way to hide all the complexity and let us use AI model in just 2-3 lines of code. And we can think pipeline as a complete workflow. And so here we are going to take a raw text, process it, and send it to the model, and we will use classifier. So what we are going to do is, okay, let's directly use a basic example of sentiment analysis, let's say. So in order to do that using the transformer, what first thing we need to import pipeline from the transformer, and then here this is the first line which tells the whole workflow what exactly needs to be done. So this is the core thing. So here when we say pipeline, when we initialize the pipeline and when we pass the task, internally it chooses the optimal default model based on the task, and it initializes that model instance, and now we can directly use the model instance to execute our task. So for example, now our classifier model is ready and I can ask, so here I can directly then pass any string to the classifier model, and it will classify this string into either positive or negative, and it will give its confidence score as well. So I love learning about AI. This is amazing. So it classified the sentiment under positive, and it assigned the score as 0.99. And then here the first thing what internally did it was, you can see no model was applied, defaulted to distill bird, distill, and so here we could have specific model for this task, and then it created an instance of this model, and it provided this input to it, and then this model classified this text into it had a choice of classifying either into positive or negative. So here the class is totally dependent on the model. This model understands this class, whether the class is positive or negative. Some other model might classify into happy, sad. It totally depends on the model. So, but in this case, the model had this two label, positive and negative, and it and it predicted it to be the input to be positive with the confidence score of 0.999. And here we can do the bulk processing also. So we can provide multiple text. So here you can see that the product is fantastic. Again, positive conference. I'm really disappointed with the service. Negative with the conference score of 0.99. The weather is okay. So here it is able to do the basic sentiment analysis. And so here we are doing it for simple sentence, but in real case scenario, the situation might be that let's say a customer support service might want to install a agent, the AI agent, which listens to the conversation between the customer and the customer support executive, and want to see how the customer service executive transformed the customer's emotion from a negative frustrated emotional state to a positive state. And so basically it can then, rather than processing sentence by sentence, it could process a chunk of sentences, uh, which is chunked into, let's say, 30 seconds of sentence, 30 seconds of messages, and then it could analysis and see the sentiment conversion from start to the end. Or corporate can, after the launch of product, they can perform the live analysis on Twitter, how the sentiment, how the product is perceived by the customer. So here we are using a very simple model, but the model can be further either fine tuned or better model can be used. So the process of using the model will be same, that you need to understand what the transformer library is, what kind of classes the model provide, how to create instance of the model, how to provide input to the model, and how to get the result and how to utilize the result. So here we used the default model. If you want to use your own model, for example, let's say we are for the sentiment analysis, we can override and use BERT based multilingual case uncased sentiment. And here this particular model gives instead of classifying the sentence to positive or negative, it classifies the text into either between star rating of 1 and 5. And here this emotion English distilled BERT, if you go to that document, if their page, so here you can see that their model is able to classify the sentence into one of the six basic emotion: anger, disgust, fear, joy, neutral, sadness, and surprise. So um, run emotion model with 3 lines of code on single text example using Hugging Face. So basically you can do the text classification. Instead of sentiment analysis, you can say here text classification, and then you can use the instance of the model and you can classify the text. So let's see the both the case. The first one is NLP Town BERT base, and then the other case. So here for this input, it is able to classify this thing as a 5 star content with a score of 0.63623. And for the second case, where we are using emotion English distributor case, and this is the input. So here this thing is now being classified as surprise with a score of 0.46. So here, um, these are kind of default model, and if you have the data set with a predefined label, then you can use that data set to fine tune the existing model, so that the score, the confidence score has a better probability score. So here it is around 0.4, and so the model is not sure whether that input has to be classified under surprise or not. So that's why the score is less. And if you have the data set with the labeled output, then you can use that data set to further fine tune it, so that when you use that your fine tuned model, the confidence score will be much higher. So the fine tuning part we'll see later, but let's go through the concept of tokenizer. So here you get the idea that how the sentiment analysis or text classification is happening in a magical way, and it is not just limited to the sentiment analysis. Uh, Here are few other tasks. So these are the few other tasks which we can use the transformer model for the NLP related application. So sentiment analysis, classify text as positive, negative, text classification, general text classification, NER. Very important thing, named entity recognition. So from the input, it is able to extract name, place, thing, time, object. So basically, it is able to extract the critical information from the input. Question answering. So from your PDF document or from your uh, a, a huge structure or unstructured information is there, then you can use that as an input, and you can then ask question based on the context. And here the context is the content, the structure or unstructured content, which is either from the text or from web or from your PDF. Then the text generation, generate text content, summarization, translation, fill mask, short classification, feature extraction. So these are some of the text-based tasks which we can use the transformer model for optimal result. So so now let's get into the under the hood, what exactly is happening. So before any text goes into a transformer model, it needs to be converted into numbers. Why? Because as you know, the internally machine are structured or built around logic gates. So that those are the building block. even not even the numbers, but logic gates. And so and the logic on top of the logic gates are are implemented the addition, subtraction, multiplication, division, all those kind of mathematical operation. And on top of that, the you can say the other kind of operation like your exponential or other calculus based thing or linear algebra kind of things are implemented. And parallelly, based on the Boolean operator, your branching condition, if condition, else condition, and all those things are implemented. So the overall architecture, there is no way that the computer can understand a simple English instruction or a simple English word. It doesn't know. It just know the most basic level the Boolean operation. So now that is the core challenge, that then how to make computer understand the any language. And so for last 50 years, there were two group of you can say AI researcher. You can say that two groups, two thinking thought existed behind the how the machine learning model should be constructed for the text based input. So the first thing was based on the semantics. Semantics as in you we can in a way can make a very complex program English Am I audible? If anyone can confirm if I'm audible. Okay, okay, sure. Thank you for the confirmation. So yeah, so there were two group of AI researcher. One group said that a kind of model can be represented using the written logic or using the knowledge representation, where the logic can be written as a code. And then there were second group of people who said that rather than having a schematic knowledge written by hand, we can have a statistics based model. So since a lot of research were done in 1950s and 70s, and whatever the transformer model we are seeing is not because of miracle which happened in just last 5 years. It was a research because it was statistics model were way back were being conceptualized in since 1950s. And one more thing, the conceptualization actually started way before even the we started uh, 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 building computer. It was way before in 1800 when Russian mathematician Markov chain. You might have heard about Markov chain. So there are statistical and probabilistical model which were discussed or formalized which revolved around if certain input is there, then what is the probability which will happen after those, uh, before the pre-existing thing. So based on those kind, you can say, the based on the Markov model, based on the neural network, based on the Bayesian interface, and the softmax optimization, different kind of mathematics are being utilized for calculating the probability of the occurrence of the next word, for the based on the input, based on the input, what the next sentence should be. So the whole thing revolves around that when we are talking about the statistical model. So now, when we are talking about statistics, so again, the word here cannot be processed as it is. And here, when we are talking about statistics, it is not just a very simple thing where you have to understand that where, how, what is its standard deviation. It is not just as simple, but it is first converted into vector space. So you can visualize in a way that, for example, let's say you have word called cat, dog, and iPhone. Now these words can be transformed into into vector. These words can be transformed into vector, and definitely when these are vector are represented in multidimensional space, so definitely the dog and the cat will be much more closer, right? So for example, if you plot a 2D graph, you can put two dot, and those two dot will be, the dog and cat will be much more closer, and the iPhone will be further away from cat and dog. Why? Because definitely they are not statistically related, right? And how this thing was established? Because when the content was feeded, so wherever, when the iPhone was discussed, so it was more about internet, electronics, application. Those kind of content were much more closer than cat and dog, right? So based on the surrounding context, the text, the word are transformed, and by transformation means that the words are away moved away from unrelated word and brought in closer with the related word. So that is the whole concept. So now here, the whole thing only works when we can represent word into vector. Vector as in a kind of, when we can point a word in a multidimensional space. So that is only possible if we can represent it as a number. So now, in order to convert word into vector, first step what we can do is we can create a dictionary. By we I mean the model can create a dictionary where whatever the word it thinks that is important or is critical or has some weight, it will add to the dictionary, and then that dictionary's index can be used for pinpointing to the vector location. So so definitely the first step is preparing the dictionary where word has an index, and also the identification of the critical words. So how those things are done? Definitely through a process of training. So when huge amount of document is fed to a model, and then the model analyzes uh, what all words are important, and so it does a thing called splitting the word, where a huge sentence is split into chunk of word. So, for example, let's say um, raining is there, so it will split the raining into rain and ing, because here definitely raining adds a tense, the present tense to it, but the underline, the meaning rain has a certain thing. So by tokenizing it to rain and ing, model handle the word in this way, that okay, rain has a vector, irrespective of tense, it will represent a state, that it represents something. And definitely the ing, the tense will again transform the vector location. So here the process of converting the sentence into chunk of word is called as tokenization. So in brief, let me repeat and get it more clear. So in order for the model to understand the text, it needs a vector representation, so that it can bring inside the model the word which are very close to each other closer, and the words which are unrelated further in the in a its multidimensional space. So in order to do that, it needs a numerical representation or vector representation of word. And now, in order to have the vector representation, first thing it needs to have a numerical representation, that a uniqueness which signifies that the uniqueness of the word. And that uniqueness of word happens because of a dictionary, and the dictionary is built by the token by the models. And when you feed the text, and the text is split into individual word which can be matched with the model's dictionary, the the process is called as tokenization. That is the chunking of text into huge sentences into chunk of word. So let's see how the tokenization is done. So whenever the whenever we run any LLM model, the first step it goes through the process is of tokenization. And whenever we hear that the chat GPT has this many million context, token context, it is talked in terms of token. So not in terms of sentence, not in terms of this thing, but in terms of token, because token is defined by the model, that uh, uh, a particular word can be consist of two token, not necessarily all the time, but sometime. So that's why it is not in terms of a word, but in terms of token. Token is something which is defined by the model, which is the sentence which is after splitting. So here we are going to use auto tokenizer, which is from the transformer. So earlier on we were directly using the pipeline. Here we are using auto tokenizer, and we are using bird base uncased. This is uh, if you go through internet, and if you want to look out for the code, you will see a lot of example based on the BERT, because BERT was the first transformer model. When I initially said that attention is what all you need, that paper when it was published, so after that this BERT model was published. So Google was the first company to launch this LLM architecture, the transformer model. But right now the chat GPT is the leader in the space in terms of you can say market capitalization. But it was the Google who, and that also an Indian. We should be proud of that thing. That Indian guy who published the paper, "Attention is what all you need," has revolutionized the modern world, and nobody knows. Most of people doesn't even know about him. And if you know, attention, it's all you need. The So basically here, Ashish Vaswani was the author, and he's a researcher. He's active researcher, but not right now part of Google. But at Google, he published this paper, and this is what revolutionized the whole uh, current artificial intelligence landscape. So yes, so we were talking about auto tokenization. So basically here we can use auto tokenizer from pre-trained, and we have to specify the model. And here we are using a default model, bird base and case. Any model you can specify, but here we are using this one. And now the tokenizer instance is ready. And now we can ask tokenizer to tokenize the text. Text can be anything. And here it will print the original text as well as the tokenized text. So here, after the tokenization, you can see uh, it is somewhat only thing difference is that I am was split into I apostrophe and M. Learning about transformer is kept as it is. So this tokenization is something not a kind of hard and fast thing that you will get this thing as it is for all the model. It is something determined by the model. And also the tokenization algorithm is somewhat pre-written before the model training is done. So if you use any other model, the token, whatever you see, can be different over here. It is totally dependent on the model. But you get the idea that before feeding anything inside the model, you convert the sentence into token. And now I already said that there is a dictionary um, which model use for converting the text into its location. You can say that internally it is represented as a vector inside the model multidimensional space. So the model builds a dictionary. For example, apple is at index 1, banana is at index 2, let's say zebra at index 3. So now there will be so now these three, the what is the now the first thing, the model defines the dictionary. Now the next thing what the model does is it assigns an arbitrary position, or you can say arbitrary vector location for these three words in its. Now since we have only three dictionary word, so it will have three-dimensional space. And now it will run the algorithm to tweak, or you can say transform its vector space to its vector space as in its position. And by transform mean move. So it will move one word from each another. Similar word will be brought together. The word which are not similar will be further, the further distance will be added to it. So here, using the tokenization, we were able to convert the sentence into the dictionary word. Now, the dictionary word can be converted into its index position. And from the index position, if we specify the index position to the model, it knows that what vector space will be, because it has memorized, it has through the during the learning step, it knows that, for example, that index 1, which represent apple, has certain location. So that index, the dictionary, when I said the apple is at 1, banana is at 2, the 1 2 3, you can say, like how in the in python or any language, when we have array at index 0 1 2 3, we can directly then access that particular element. So in similar way, we say token IDs. Token IDs are something that it is a number which directly correspond to the token. So here, what are we going to do? We are going to use the same tokenizer, and instead of tokenizer, we will call convert tokens to IDs, and we are going to pass the tokens. So these tokens will be converted into unique IDs. So what are these IDs? These are the IDs, you can say as index of the dictionary, which model understand, and model can use these index to resolve what location it has in its multidimensional space. So this again represent a vector internally. This is itself not a vector. This is just a indexed number, but the model has assigned to this index a unique vector space. So here we are here in the first step, we are converting the tokens into the ID, and again then we are converting. So what happen is, you feed the token IDs to the model, then model does the transformation and gives you the output. You take, and that output will also be in the form of token IDs, and then you convert the token IDs to the token. So let's say here we are passing same token ID, but let's say if the token ID is from the output of the model, and then we convert it back to the token, back decoded token, and then we can use tokenizer so to convert into full encoding. That is the full sentence. So this is a kind of whole process. So the only thing missing over here is feeding it to the model and getting the output, and the output is in the form of, not in the form of only form of token ID, but logits. We will see that thing also. But the whole process is this, that you convert the sentence into individual token ID, and then token IDs, sorry, token, and then token to token IDs, and you feed the token ID to the model. Model again returns the token ID, and then you decode the token IDs. And then we have token mask. So for example, here, when we first let's try to understand what attention masks are. The attention mask tells the model which tokens are real content or which are padding. So a value of 1 means pay attention to token, and 0 means ignore this one. So for example, here the sentences of two different length, and here when we when we convert into the token ID, so you can see that these have ID text IDs, and the rest of the thing has 000. And token mask, if we see, then one represents that there are token and zero means it's missing. And the second sentence has the all the word has its ID representation, so that's why second has all over test mask is there. And then there is special token. Each model use special token for different purpose. So 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 here clears. Full stop is separator 102. Padding, that is when the sentence is sentence and there is nothing after that, so zero is used. UNK token. So these are the special tokens. Whenever the sentence starts, CLS is used. And then mask token we have already seen. So those are the kind of special token which model uses, and it totally depends on model to model how internally it uses special IDs. So those were so those are kind of basic thing which all model utilizes under the hood for converting uh, text into chunk of pieces of text, and then text to text IDs, so that internally it can uh, use the use to find its vector position. Now uh, that we understand the tokenization, let's look the model themselves. So Hugging Face provides an easy way to load any model, and we can use auto classes for that. In our previous, initially, we use pipeline. Pipeline under the hood directly use the tokenization and the model initialization. But let's say if you want to do it from scratch, we can use auto model from predefined, and here uh, we are using bird based uncased default model. And here, for example, let's say if you want to initialize classification model, then we can use auto model for sequence classification, which can be imported from transformers. And then we are initializing the classification model. So here, this way, that these are the two way by which we can initialize the model. One is without task specific, directly we can specify from trained and model name. And another is task specific. We can use task specific class, and from that we can call from pre-trained and specify the model name. So these are the two way of loading the model. And then so how to make the prediction. So under the hood, the prediction happens in this way. So here we we will see using the second type, that is we will load a model with classification head. Here we will do that. uh, Model name we will specify. So tokenizer is ready, our model is ready. We will first tokenize the text, which is this text, into input. And here The model is the instance of our auto model for sequence classification task, which is based on this model, which utilizes this model. And when we execute the model with the input, and where input is the instance of uh, tokenizer, so internally it represents the it is the token representation of the text. So that is fed into the model and we get the output. Now the output is in the form of logit. So logit has, you can say that logit doesn't have a upper bound, so or and the minimum bound. So we use softmax. Softmax is a mechanism, is a mathematical formula to compress and uh, uh, reduce the maximum to +1 and minimum to -1, and then in this way we get the probability. So here for this particular input, it is now classifying it as positive and with confidence score of 0.99. So under the hood, you can see when we were using the pipeline, we in two lines of code, we were able to classify the text. Here we had to, in order to have a control, we had to first tokenize ourselves, tokenize the input. We have to create model instance ourselves, then create the get the output from the model, and then use the softmax function to squeeze to convert logits to probabilities, and then get the prediction using argmax. So here multiple step, using the pipeline we can convert this multi-step into two lines of code. So that's the benefit of pipeline. But definitely when we want to have a control over flow of code, then we can use our own custom code. Otherwise, we can use the pipeline. So we will use, we'll see one more few, let's see two couple of application of uh, our pipeline based application, and then we will conclude our session. So there is one kind of common NLP task which is called as NER, named entity recognition, which revolves around extracting the named entity from the text. Named entity can be name of the person, place, organization, and so on. Name, place, thing. So here, this is the input. Here, I'm creating the pipeline instance for the NER task. Here, I'm not specifying the model name. I'll let default let the pipeline choose the default optimal model, and then I will pass the NER instance, NER pipeline, the text. I will pass the pipeline instance the text, and it will print the entities from the text. So here it is using BERT large case fine tuned Cornell 103 English um, model. So here you can see that it was able to extract the following entities. This was a text, and it is able to extract Apple Incorporation as an organization, Steve Jobs as a person with the following conference score, uh, Cupertino as a location, California location, Tim Cook as a person. So you can see that it is easily able to extract the entities from the text. Here, the entities are the categories of the entities, for example, organization, person, location, are defined by the model. That is, during the training, we decide uh, what are the entities the model should support. So definitely a particular model can have uh, maybe hundreds of entity type. For example, we can build our own entity type based on the use case for an organization internal purpose. So similarly, let's move to one more example. Here we will see the question answering pipeline. So pipeline question answering. This is the input, and here is the question. So based on this context, which is going to remain same in each iteration, we will iterate over the question. We will feed this as the input. Input as in for this context, we will ask this question and we will expect the model to give an output. So here you can see the context remains same. Context remains same in each iteration. Questions get updated. So here QA pipeline instance, we are passing question. Question is we represent a single row, and we pass same context and we get the output. So the question is what is the uh, what how tall is the Eiffel Tower? So here the particular text is there, and this is can see only 261 MB model, very small model size, and it is able to answer the question: how tall is the Eiffel Tower? 330 meters tall. Who designed the Eiffel Tower? Gustav Eiffel Engineering Company. When was the Eiffel Tower built? 1887 to 1880. How many visitors did the tower? So you can see that in this way you can implement a question answering application from any TensorFlow based model. So today let's conclude our session. So these are the basic. Here we try to learn two things. One was uh, how the how we can use Hugging Face transformer to implement the NLP pipeline, and the other was to understand how the internally the transformer model work. We didn't get into the depth, exact depth, that how encoder and decoder works, but basically to understand how the tokenization work, and how that tokenization is converted into ID token IDs, and then token ID internally model knows what vector position it has. Um, so we just covered the basic aspect of those things, and we learned a few of the application of NLP. And from your own end, you can try out different uh, NLP tasks. For example, text generation, zero shot classification. There are a lot of things you can try on your own. So and then definitely there is a fine tuning thing part which also needs to be focused on. So anyways, on your own, I expect that you learn different kind of NLP, utilize the transformer model, and implement different kind of NLP application from ranging from translation to summarization and zero shot classification. And bye bye, have a nice weekend. So can we get the recording of this class? Yeah, sure. uh, you will get the recording, and by Monday you should get the recording of this session. Bye bye, have a nice weekend.